So Dr. Runge, let's talk about, you've had a illustrious career. Why don't we talk about how you actually got started in the finishing industry? How did it get you right out of your training and into the profession?
Well, my bachelor's degree is in mathematics. My master's degree is in metallurgy. My very first job after getting my master's degree was at Northrop Corporation in Rolling Meadows, Illinois. At the time, they were the Defense Systems Division, and they made electronic countermeasures. And in the countermeasures was a plethora of finishes. So, like most people, I think, who are not born into the
Hmm.
industry came to me. There was all of this metal finishing for me
Hmm.
to study and understand because I worked in the reliability analysis laboratory right out of school. I had instrumentation knowledge. I knew how to work the scanning electron microscope. I knew how to do metallography and image things microscopically. And so this is more or less where I encountered metal finishing, but mainly in terms of electroplating. And this was for the technology at the time was surface mount technology with
Hmm.
small microcircuits, hybrid microwave circuits, where this was a tab on contact type of
Right.
contacts. And also, solderability.
Mm.
I
Yeah.
got involved in electron tubes, so I was making seals, vacuum seals for um, vacuum tubes, and
Right.
so I was joining ceramics to metals. So between soldering and brazing, which
Mm.
are metallurgical processes,
Right.
we
Hmm.
have the different interfaces that we need to work with. And in the lion's share of the metal finishing, therefore, was different electroplated layers with the
Hmm.
top layer for solderability and conductivity. With radio frequency, we did a lot of, or RF devices. There was a lot of silver because RF is conducted on the surface. And so high conductivity, we had
Hmm.
silver. Um, that led to other coatings. So
Hmm.
metal filled epoxies were of interest, um, easy to dispense and conductive. Um,
Mm.
uh, Different conformal coatings to protect the circuits from
Right.
corrosion and external moisture. And it's interesting, all the pink poly that was circulated because I started in 1982. I got my bachelor's in 79 and my
Hmm.
master's in 82. Um, so we just got done talking, been in the industry for over 40 years now.
Right.
But just knowing what we thought we knew was we need to have conductive polymer. We'll load it with sodium lauryl sulfate, make pink
Mm.
poly, and our problems of electrostatic discharge go away.
Go on.
You end up with corrosion as well.
Mm. Yeah.
So it's been a very interesting progression, all non-ferrous.
Mm.
Always working
Right.
with copper and copper alloys, and then tin, tin alloys, nickel and nickel alloys, and the chassis to come to where I ended up in the long run. The chassis were all aluminum.
Ah.
And these chassis were conformally coated, not conformally coated, excuse me. They were they were conversion coated. That's where the two C's came out
Sure.
wrong.
Yeah.
Uh,
Yeah.
and in conversion coating, of course, you get that at the time because chrome was everywhere. You got that beautiful golden green color that
Mm.
told you it was there.
Right.
And so this is where it began. And then every now and then a part would come through that was anodized. And I
Mm.
knew I'm a metallurgist. We learn a lot of thermodynamics and diffusion.
Right.
Um, we do learn some chemistry, but it's lean, and so it's way back here.
Right.
I would depend on the chemist to do the
Right.
chemistry, and do and have. But at the same time, looking at the precipitation kinetics, understanding how alloys then electroplate in from solution to your surface, and how you get the microstructures you get become key to how you process them later, how well
Right.
they bend, how
Right.
well they solder,
Mhm.
how well they plate through a hole.
Right.
So all of that became key and foundational for learnings that took me to my next job.
Well, let me ask you a question if I could jump back. What is it, metallurgy as a field of study? What led you to that, though, in your college career?
Oh, that's a great question. Yeah, I'm one of 9 kids,
Hmm.
and I was the first one to go to college. My parents didn't go to college. Their parents didn't go to. I was the first one to go to college, and my mom, God bless my mom, in her mind, the best profession in the world is a medical doctor. And I was going to be Judy the MD. And I knew from the time I was a senior in high school, that's not what I wanted for myself.
Right.
But when I left to go to undergrad, I was intimidated. I didn't know what to expect, what to know. I graduated at the top of my class. I had a full ride scholarship. I ended up going to a small private college, Illinois Benedictine College in Lisle, Illinois. And they had 100% acceptance to medical school from their pre med if you took the biochemistry program. Well, I did that. It was
Mm.
really, and I found out just what I knew in my gut. I didn't like it. I
Right.
didn't like. I didn't like.
Right.
I didn't
Right.
like the subject matter at the time. I didn't like my classmates. So I ended up switching majors to math,
Hmm.
and I took a minor in physics. And I had so many college credits from high school, I could graduate from undergrad in 3 years.
3 years. Yeah.
If I stayed at the fourth year, I would have had physics and math, which was
Mm.
extremely marketable. But I decided I'd follow a boyfriend, and
There you go.
and and so it's coming. The story's coming to an end. So I was sitting with a group of girlfriends. I said, I don't know what to do. I know I can't take a math, continue in the world with a math degree. And one of my girlfriends said, why not go into engineering?
There you go. Yes.
And
Which.
her boyfriend at the time was in bioengineering. And I thought, oh, I could satisfy my mother.
Yeah. Yeah. Yes. Check a lot of boxes there. Yes.
And get a marketable degree. So I went into U of I at Chicago
Hmm.
in bioengineering with a focus in materials.
Mm. Okay.
My thesis advisor, William Rostoker. So you asked me also about my mentors.
Mentors. Yeah.
He was the first one. He was a metallurgist.
Mm.
And he had a whole research group that I was
Right.
part of. We were doing research in titanium fiber metal as as implantables for prostheses.
Okay. Sure.
And my master's thesis was about an acetabular prosthesis, so the hip socket.
Right.
And
Right.
what was unique about these is that they were, we manufactured them from small sections of titanium wire,
Mm. Mm.
and we would mechanically form them into a compact, sinter it, and then backfill
Mm.
it with an articulating surface of ultra high molecular weight polyethylene.
Wow.
Um,
Yeah.
Yeah,
Interesting.
it was a
Interesting. Yeah.
very, very cool project. We learned about, the thermodynamics and diffusion that go on during high temperature processing of titanium, the microstructure of the titanium. It was a great project, and that was my springboard
Springboard into it. Yeah. And
into.
you mentioned something earlier. You said that it kind of found you. I guess when you got into it, is that something that you really thought this is some really cool stuff? This is really something I could really dive into as a career when you were even having your first job outside of college. Did it
I
feel that way or?
I felt extremely fortunate
Hmm.
for a variety of reasons. First, to get the job, because the market in 1982,
Hmm.
that was a tough time job
Right.
wise. I got in. Reagan was president, and a lot of DoD dollars were available, and
Hmm.
so Northrop what was hiring like gangbusters. No one else
Hmm.
was. I went to all the different steel mills in the area around Chicago,
Right.
and nobody was hiring,
Hmm.
and I was nonferrous. Who would hire
Right.
me? So getting into Northrop was great. Then getting into microelectronics
Hmm.
and the manufacturing of circuits, and all of the different
Right.
processes associated with that, including electroplating. This
Hmm.
was this was this was just a wonderful, um, broad spectrum of
Right.
opportunity. It was fantastic. It was
Yeah.
fantastic. And for years after
Yeah.
leaving Northrop and working, and supporting big companies like Motorola and AT&T and all these different companies that made circuits and different automotive companies that
Right.
use circuits and the Joe Robbie Stadium exploding scoreboard.
Really? Oh, I do remember that. Yes. Yeah.
I worked on that. Um,
Yeah.
all these different things were because of my foundation
Right.
in electroplating from Northrop. So
Right.
it finds you and I think it's how one continues with it.
Right.
And this is what I try to tell young engineers. If you see it and it excites you, then you've got to dig deeper.
Deeper into it. Yeah. Yeah. It's funny. I mean, people know you, I think, as a researcher and the papers and the presentations they see you. And some may not know you spent many years in a job shop, right? And in an
Yeah.
electroplating shop, really. How was that experience? I know working for Mr. Saporito there. Tell us about that. How did you get into that and how was that experience for you?
Well, for after I left Northrop, I worked for 10 years at a consultancy in Skokie.
Hmm.
It was a metallurgical consulting firm called Tausig Associates.
Hmm.
And the Saporitos were a good client of mine. It was Tausig was great if you developed your own client base,
Hmm.
and so I had Jim Moravli,
Hmm. Hmm.
and Charles Saprio Jr. Were real great clients, asking me to support and help, sometimes through characterization, sometimes through process review, and get us doing something new, Jude. And so, we had a real nice working relationship. And after I was at Tausig for 10 years, they were bought out by a laboratory. Well, it's a big conglomerate called Bodycoat. They mainly do heat
Yeah.
treat,
Good.
but they also had a laboratory division at the time, and they bought Tausig. And the dynamic changed because we would do these,
Hmm.
and especially the engineers. And I was at the time finishing my Ph.D. Because I had my kids, and then I went back to school. My youngest was 3 while I was at Tausig. So this was
Hmm.
a time where you I want to come around again. That that I was developing these important relationships
Hmm.
so that I would continue to work afterwards. When Body Coat bought Tausig,
Hmm.
like I said, that dynamic changed. I
Right.
couldn't do these deep dives anymore. And I went to Jim Mirabile and I said, Jim, did you ever think of hiring someone like me?
Right.
My PhD thesis was in anodizing, was in using complex electrolytes to develop oxides with unique characteristics. I didn't know that at the time. I just thought I could make a conductive oxide by using electroactive polymers in the electrolyte. Made a it was successful. But anyway, wanting to develop that further
Hmm.
at Saporito, and Jim was game. Jim was open. Charles was game. Charles was open. And so what was unique there was I could continue to do the research. I could work the different processes, and so continue in electroplating,
Hmm.
develop anodizing. I had my own little line in my own
Hmm.
little lab. It was a very nice lab. Um, and they let me consult out of the lab.
Wow, that's a
So
great mixture to have
it
there
was
with
a
that.
great
Yeah,
gig. It really
right.
was. And
Well,
I,
and it also gave you an idea of how shops run, how these
oh my
manufacturing
goodness,
facilities
yeah.
run, right? Where they make the money, how they make the money, where they lose money, where they have problems. To be inside, I guess, gives you a great perspective, especially since when you are have been consulting and still are consulting with people, knowing what it is they're trying to do and how they operate. That had to be great insight with that. So.
It was incredible because when as a researcher and an engineer uh, with ideas, sometimes you think, why not? Why aren't we diving in and doing this right away? Let's go, let's go, let's go. And it's no, we don't make our money that
Right.
way.
That's right. Yeah, Now we talked about a couple of people there, and I did want to touch on that. We talked about mentors, and everybody. I think every successful person has some really good mentors that really help them along the way early. Were there for them. Maybe you could reach back and talk to somebody if you needed some advice or just to kind of rely on. Who were some of the people that in your career, early, mid, and even now that really has because I even today I will find a mentor, right?
Oh
And
yeah.
yeah. So who were some of the people that really helped with you with
When I was first out of school, I was never shy
that? Hmm.
to call my old professors.
Hmm.
And Bill Rostoker, David Levinson, Mike McNally, they were the core, the people. Bill was my master's advisor, Mike my PhD advisor, and this was all at the U of I here in Chicago. Um, when I got to Northrop, I still called on them.
Hmm.
Um, when I got to Tausig, uh, um, and you meet these icons in military electronics
Hmm.
that I learned about thermosonic wire bonding from the
Hmm.
guy who developed thermosonic wire bonding. Um,
Right.
I the vacuum tubes of Raytheon and different people that we would work with, they liked that I was curious and wanted to know more. At Tausig, there was a plethora of different metallurgical experts that I continued to learn from, and and Corwin Berger was my boss
Hmm.
there, and was a really he trusted me. He gave me a very very long leash.
Hmm.
Um, Going to
Great. Yeah.
Saporito, now we're focusing now down into these icons in metal finishing,
Hmm.
and it was at Saporito, for example, that I met Charlie Grubbs,
Hmm.
who is an anodizing expert. And Charlie is the first one who brought me into then AESF. And I was his co-chair for the light metals finishing committee from I want to say like 1997 to 2006. And as he saw that I could do it, he was able to drop off, and I took off my training wheels, so to speak, and I
Learn to fly. There you
yeah,
go.
yeah, really did.
Right.
So Charlie was great. I met Walter Dalla-Barba at Saporito from Etel Techno, and Walter is, I would say, just a metal finishing icon. Walter is also a metallurgist like me, so his biannual conferences are soup to nuts. Tim, they're wonderful. They start with casting of aluminum and go through
True.
metal finishing, and it's every aspect of metal finishing. And
Really?
Walter
Right.
is familiar and understands and knows these things. So also, while at Saporito and at the end of the tenure at Tausig, I was doing my PhD, and I was extremely fortunate to work with Macron Associates, a laboratory in the suburbs of Chicago.
Right.
Don Brooks owned the company at the time,
Yes.
and Don said, "Judy, you are working on your PhD. You have access to our laboratory and the team here." And I worked very closely with Steve Rice. And this is key, Tim, because with Steve, I started my characterization of anodic oxidation and anodic oxides. This is a study that I think I've pioneered. I don't see anyone using it as extensively as I have over the last 40 years plus,
Right.
to understand anodic oxide nucleation and growth and the impact the aluminum and its alloys has on how that oxide grows.
Right. Yeah. Okay. I think it's important because a lot of people who are in the industry consider themselves an anodizer or a finisher, may not get to that level of understanding what's going on, right? And it is key to have some understanding of what are they doing to the substrate, what is happening, what may it do. Like I said, not all materials are created equal, right? So you've got to have a good understanding of what may occur, what will occur. And really, I don't think, like I said, a lot of people have taken that deep of a dive. It's something that really interested you, I'm sure, with that.
Yeah, and it really does account for that other end of the process. When we think of if you look at both sides of any metal finishing process, you have the metal that you're finishing, and you have what you're doing to it externally. It's that interface, what goes on at that interface. And that goes all the way back to my Northrop years, interfacial phenomena, what is going on there. And especially with anodizing, we're not just covering the surface, we're growing from that surface. We're consuming that aluminum, and only aluminum anodizes. So what are those alloying elements doing? What are the inclusions doing? What's happening at that interface? And people are so fixed on coding that the general consensus has been, I hope I've been able to debunk it over the years, but the general consensus has been, you get a barrier layer, so it's a contiguous layer of oxide, and then you dissolve regular pores in this layer and it grows and you have an oxide. It's not how it is. It's a nanoscale network of individual oxide cells that are spaced according to the polarization of the surface. So it's different, and those little cells are all going to grow at the same rate unless they get interrupted by something. And this is where the microstructure, the condition of the structure, how clean it is, everything comes into play, and what drives its growth.
Right. Hey, I want to get into your in a second here about talking about the book that you wrote, but in talking about that, when did you discover that that wasn't the case and it was something different? I mean, had you been led to believe, or had you maybe not been led to believe, and it's something you came across with that? Do you remember? Was it an aha moment with that, or how
Yeah,
was it?
yeah, it was really the late 90s, and it was during my time
Really? Okay.
working on my PhD. The first paper I wrote was for the Aluminum Surface Science and Technology um, conference in Manchester, England
Hmm.
in 2000. And this, I mean, I got to give Saporito credit here. They were behind me. They
Hmm.
wanted me to understand this. They sent me to England. And how many metal finishers actually do that with their staff? And they
Right.
sent me and they sent my technician with me.
Hmm.
And I gave, it's where I wrote, I think it's called New Insights to the Nucleation and Growth of the Anionic Oxide. I believe I've
Yeah, I
shared,
believe we ran. Yeah, we ran that for. Yeah, yeah, we did run that, and yeah.
and I'll never forget Aaron Pomus was my tech at the time, and he read the paper and he said, "Judy, I feel like you're at the top of the ski hill and the tip of your skis are there, and you're getting ready to just go down because at the same time." I wasn't sure 100%.
Right,
Now I am, and I know so
right,
much more. But then I didn't, and this was 25 years ago writing that paper. Um, and I didn't want to insult anybody. I'm such a good kid.
you're
And
right.
and so I had all this instrumentation, the
Right,
state of the art. I was looking at these things with a transmission electron microscope, understanding the structure, seeing the deviations at the interface with the metal, and saying, this is so different
right,
from what is in every book, what is in
right,
Warnick, Pinner, and Sheesby, what's been written in Fraunhofer, all these different
right,
books. It's
right,
not what they say. It's the benefit I have of the state of the art analytical and characterization equipment that is enabling me to do that. Tim, I was able to utilize through a laboratory in
hmm,
Atlanta called Millette Vanderwood the synchrotron.
mm.
This is how fortunate I've been. The synchrotron at Brookhaven National Laboratory to
Oh
do
wow.
FTIR through the anionic oxide with my specialty um, electrolyte, with the modified electrolyte that has the electroactive polymer in it, and do stepwise, micron-wise steps through the
Mm.
oxide, characterizing its chemistry to show the effects
Right.
of
Show
the
that.
of the
Interesting.
incredible work that
Right. Mm.
I'm not, and I was working in industry,
Right.
and
That's rare, right? I mean, if you're not just dedicated 24 hours. Let me jump to the book, and I want to come back though to this part of this, like I said, these misconceptions that people have. So the book, and I love the title, with the metallurgy of anodizing aluminum, connecting science to practice, right? And I've always felt that way, that science is a practice and you've got to keep practicing to get better and everything. Tell us about what made you decide you wanted to. Was it that discovery that you thought, I'm going to put this down because people need to be taught that in this book? And it's a great book, and like it's still available, people can purchase it. But tell us about the process. What made you decide to write it? What you went through? How long it took you? Talk about that for a minute.
um, I had been in the industry about 30 years at the time, and
Mm-hmm.
I had beautiful data from the time I was at Tausig, all these years of different interfacial phenomena, and my thesis work was groundbreaking
Mm-hmm.
when it came to understanding anodizing. And um, I had said to my husband, my goodness, I have so much wonderful data here.
Hmm.
that no one else has done.
Right.
To the point of working in industry while I'm doing this,
Right.
these were not perfect circumstances. These
Mm.
were imperfect alloys. These were industrial processes. This was not done in a beaker in a cute little, and I don't mean to say anything that says that graduate school is not representative, but it's not when it comes to
Right.
metal finishing.
Right. Right.
You're,
Right. This is real life stuff that you were doing. I
yes,
mean, in the
thank you.
process, right?
Thank you.
Yes,
That is
real
everything
life
I
as you
just
do
said
it.
in a nutshell. This was the
Right.
real life that I was working with. And I had just given a paper for
Hmm.
Walter Dalla Barba at the Aluminium 2000 conference, I think in 2012. And Tim, I gave the latest version of base metal microstructural considerations for anodizing aluminum,
Hmm.
which is a paper I had begun in 1996. And I
Right.
had revised it and revised it and revised it over
Hmm.
the years. And now it's part of the AAC
Hmm.
Anodizing Essentials program.
Hmm.
Um, but in doing that, writing that paper, there must be editors at different publishers that review proceedings.
Right.
I
Yes.
got a email from Anya Levinson at Springer Nature
Hmm.
and said, read your paper, loved it. Have you ever thought of writing a book?
Right.
And I said, oh my gosh, after talking to my husband and saying,
Right.
write a book, I get this, what
Right.
grace am I getting? And so I was at Apple already at the time.
Oh, okay. Already working. Yeah.
I was
Hmm.
already working for Apple, and I had been there for 4 years working
Hmm.
under contract. And I signed the contract to write the book in 2013,
Hmm.
and I started writing it in October of 2014, so almost a
Hmm.
year later.
Wow.
So, because
Right.
I had to finish my contract, and then I went to Germany and I started writing the book then when I was at
Right.
my home in Germany. So how long did it take? It took about 3.5 years.
Hmm.
Not of
Wow.
constant
You say
focus.
you're working on your
Yeah,
job.
yeah, well, I took a leave of absence, but I still was doing consulting. It was during that time I did some really nice metallurgy on aluminum forgings, um,
Hmm.
and also did some work at Novellus and different companies. But these were small, compact jobs, and the book was overarching.
Right.
Um, it was it was a knot in my stomach, Tim. It was a
Right.
real hard thing to do because I had all this wonderful things
Right.
to say. Um, so what did I do? I started with what was most comfortable, and it turned out a very big learning experience. I wrote the
Hmm.
chapter on aluminum metallurgy.
Hmm.
So you start with where I went home. I
Well,
went
right. To the
to
back to the basics. Right.
yeah, and what I learned, Tim, was if at least in my experience, you don't have to write a book from the chapter 1, in my case, to chapter 8. I started
Hmm.
with chapter 4, and then I went back to chapter 3, and then
Right.
I went
Hmm.
to chapters 5, 6, and 7, which, by the way, of the book, 5, 6, and 7, that's the meat of the
Right.
book, really what you got to
Right.
get your teeth into.
Right.
Chapter 8 is case studies, but before I did that, I wrote chapter 2.
Right. Well, when you go back and look at it, it's building blocks, right? Of
Mhm.
putting it together, knowing that somebody who's going to be using this either for a college course or anything else, they're going to be going from front to back a little bit, and building that process with them. And yeah, like I said, I should mention I love the book because they have some wonderful illustrations that really explain
Yeah.
what it is you're saying. I mean, you could say it, but if you can find somebody that can help you, I know you had somebody that really helped you with that.
Oh
'Cause I
my
see a lot of your
gosh.
papers. Yeah,
Yeah.
really helped you with that.
In fact, we're neighbors. She, Joy Kaufman is my
Yeah,
illustrator and
illustrator.
graphic artist, and we would actually sit side by side. I would say, this is what I have in my mind. This is what's really happening. Um, I, yeah, I would say, do you remember, Joy, going when you were in school and the human anatomy book, and you would open the book to
Open.
the middle, and it had those cello pages
Yeah,
that had
overlays a little bit.
parts of the
Yeah.
body. And I said,
Hmm.
that's what I want. That's what I
Right.
want for this book.
Hmm.
And I said, and we're going to make a video, and we will, she and I, we will make that video.
Right.
But Joy is so brilliant. She took what we would say. She would say, now you got to give me some time.
Right.
And she would take a night, she would take a couple weeks, and she'd get back to me. And by gum, if those illustrations she had made were not to scale,
Mm.
they were to scale, with
Right. Wow.
the
That's
ionic radii, and making sure that what we were seeing in those TEM micrographs
mm.
was not represented then graphically to scale.
Right.
Um, Brilliant, brilliant. And I
Right.
have to say, you are absolutely right. It sets
It,
this book apart.
yeah,
It's
you want to read it and look at it, read it and look at it. And like I said, 3.5 years. I mean, I know you have how many children? Four, five, four,
4 kids.
right? This had to be the biggest baby you gave birth to here, because this
Yeah,
was a long time, right?
it
My
was.
question is, with all that, putting that research in it, and really, you were bringing through research that maybe some people didn't know about, they hadn't recognized, or they didn't want to recognize it. But what kind of reaction did you get from some people when some of the theses that you're putting together about uh, the the layers and things like that you had talked about? Uh, did people start coming around to it a little bit more, or?
I would say, yeah. It a
Mm-hmm.
lot depended on what it wasn't met with a lot of applause.
Mm-hmm.
It was something that was recognized, obviously, as a game changer. It was also a challenge,
Right.
and I just to mention mentors. Um, oh gosh, Tim, I've been so lucky.
Mm-hmm.
While I was at Saporito, I met um, Moise Lerner.
Mm-hmm.
Um, I was really first recognized as an anodizing expert in 1996 by Charlie Roberts of Universal Metal Finishing. I mean,
Mm-hmm.
I was working already in the metal finishing shops, in the electroplating shops that I worked in and visited while I was at Northrop, while I was at Tausig visiting, while doing support work and consulting for clients. So Moise Lerner from Sanford Process, who brought technology from Ukraine, Russia area, and challenged the industry by saying, "This is a semiconductor, guys. This isn't an insulator. It's a semiconductor."
Mm. Right.
He honored me in 2003. He was dying, and he
Mm.
said, "Judy, you're the only one who gets it. Can you give my paper?" And I gave his
Wow.
paper
What an honor.
at
Yeah.
just and Milt Stevenson Sr. came up to me, and this was in Chicago in 2003, and he said, "It's no wonder Moise trusted you." He said to
Mm.
me, "You're the only one who gets it."
Right.
So
Wow. That's quite an honor. Somebody, someone like that
yeah,
to have them
yeah.
do that for you.
I
Yeah.
also
That's. I
met Arthur Brace in
was gonna say he, someone who people
1996. Talk
people
about
consider.
the grandfather of anodizing.
Right.
Arthur didn't like me. He loved me, but he didn't like my. Yeah, he thought my work was fascinating, but he didn't want to change the
Right.
basis of anodizing, because it would conflict with everything he's done his entire career. I said anodizing is controlled corrosion. He said to me, corrosion has no order. It can't be
Mm,
corrosion. I said, well, but if you control it, it does. And
right.
that's what we're doing here. This is not equilibrium reactions. This is non-equilibrium reactions.
Hmm.
Um, uh, Charlie, Charlie Grubbs. Now it's
Hmm.
Charlie Roberts, Charlie Grubbs. Charlie Grubbs got it. In fact, Charlie Grubbs didn't like people calling the oxide a coating. He wanted anybody he taught to call it an oxide.
Mm, right. Wow.
And
Interesting.
yeah, so that's forward thinking. Um, I was,
Well.
there's George Thompson from UMist in England. He
Mhm.
had a whole group of kids over a number of years, a prolific author, a prolific advisor. It's hard to see papers that he,
Mm,
he, now George saw me as competition, but
right.
I
Right.
wasn't academic. I was industrial. And this is where, for me, in supporting the industry, my industrial characterization and work and research exceeds that what you can get academically.
I was going to say it's a little bit more, and I know that there's a bias sometimes, right, of
Mm-hmm.
whether you're going to spend all your time with that. And it's I should say if anybody, I've read a lot of your papers, and I always run at the bottom how they can get the book. So anybody who's watching this or listening, uh, go to finishing.encoding.com, search your name. When they find an article, it'll be on there with that because it is a book still available, and I think every time I run your papers, I get a note from somebody. Even though it's right there, they'll say, "How do I get that book?" And I give them the link, and they can go get it with that. So you mentioned you talked about it earlier. You were worked for Apple for many years as a contractor, and then they brought you on, and they wanted you there. And if I'm just going to, we haven't talked about this. I know that for a time, Apple was really changing the way they were using their materials. I know they were using more color, but were you working more internally on these devices, or was it, because their devices are so beautiful? I know that's the way they want the products to be looked at, that be held and admired, and it's all surface finishing. But what was more of yours? Was it internal or the external part of it? What was it with that?
Oh, it's definitely the external part.
Okay.
Any aluminum housing on most any of their products.
Hmm.
I have worked one way or another on. I was um, I worked on phone, and way back when I worked on iPod and the
Hmm.
MacBooks, um, and when you say was it the anodizing, was it the color? I again, it's I'm not a one trick pony, but I'm a stubborn mule when it comes to tying the process to the base material,
Right.
and I really did drive that home at Apple, and showed them, the need and for characterization and understanding of what is going on. At at that metal oxide interface, because believe it or not, that oxide is transparent.
Mm.
When we look at it in onyx oxide, we are looking through that oxide to the interface with the metal, and every grain boundary, every particle, everything, if it is big enough, we will see.
Right.
So when you think of Apple products and how absolutely gorgeous they are, and that they're made everywhere, there's
Hmm.
not just one anodizer. They're
Right.
made everywhere. The amount of understanding, control, um, and and um, and then the post processing, the color and the seal, that understanding those processes over that scale
Right.
is just an
Mind.
amazing
It's
feat of
mind-boggling with that. Yeah.
engineering and manufacturing. Yeah.
So from what I understand, I guess they didn't really have a big surface finishing team when you were there, when you started, correct?
No, not when I started. In fact,
Now it's grown, right? And we're talking about U.S. based with all that. Um, and that must have been exciting for a company to build something up like that, to bring people on. I know you've got a lot of, I see a lot of the engineers, like a lot of young, bright minds with that, right? But how was that process of really bringing them on and kind of, working with them closely, especially when you have a company that has such high quality
Yeah,
demands, high quality demands?
it was fascinating, and it was, oh my gosh, so stimulating.
Hmm.
I had the pleasure of working so many different places. Like you said, from the ground up, from the gritty to the ivory tower,
Right,
and Apple is a fabulous mixture of it all.
right,
And when I talk about soup to nuts, from the casting to the metal finishing processes, everybody had a hand in making these alloys and then making this metal finishing process its absolute best.
right,
And today, what they're doing to essentially by next year have a 100% recycled product through
right,
the entire product line. And
right,
then by 2035 being carbon neutral. I mean,
right,
these are impressive goals, but Apple's making them reachable. And it's
right.
because they engage the whole team.
Right.
It's
And for lots of you all had to almost invent new materials, new 7,000 series for watches, and how they want to make them thinner and stronger. That's
yeah,
not, you don't say that in a sentence office, right? Make it thinner but stronger, make it more durable, and
yeah,
things like that. And then repeat it 25, 30 million times
that's
is a
correct.
task, I'm sure, to get that
Mhm.
process down just right.
Yeah.
And so you worked up into them. I think it was last year. You sort of
I
retired from that, but
retired. I retired in July of 2023. Yeah.
from Apple, but you still kept your company, your private consulting company,
Yeah.
and Comcode. Is that correct?
Yes, correct.
Comcode. And so, what's the next year? What do you want to do? You're not just going to. I know you've got a home in Europe and you've got family here in the U.S., but you still are going to stay in the industry, right? And tell us how are you going to do that?
I have too much energy to stop right now. I just don't know. It's hard enough. I'm walking around with one of those awful orthopedic boots right now, and I can't sit still. I really I'm looking to write more. I'm looking to teach more.
We'll talk
I'm
about that because you just taught a course, and I wasn't even aware of this facility. Now I'm going to be getting contact. University of Kentucky, correct?
I,
A group. Talk about that for a bit. You just taught a course down there.
I did. Thanks for recognizing that. At the Center of Aluminum Technology at the University of Kentucky at Lexington,
Hmm.
there is an aluminum metallurgy certification course. This is for anybody in the industry. You do not have to have an engineering degree.
Hmm.
So you learn over 4 intense weeks throughout the year. So each quarter, 1 week, um, aluminum metallurgy. Um, I taught surfaces and surface finishing during the
Hmm.
last week in 2023. It'll be in the third week um, this year, so it'll be in early September. But you go through, you can't, it's not only classroom, it's also laboratory. So
Hmm.
you do get to cast, you get to
Hmm.
machine, you get to do your laboratory preparation.
Hmm.
You see how to understand the mechanical properties of the material, and at the end, you get a certificate. This is
Hmm.
not an engineering diploma. Please don't
Right.
misunderstand that. This is a certificate, and the group I taught had amazing synergy.
Hmm.
These were laboratory, all the way from laboratory technicians, engineering planning managers. We had a metallurgical engineer, but we had a lot of quality engineers that were
Hmm.
not metallurgical engineers in this class.
Hmm.
And the synergy was incredible. incredible synergy.
Wow,
Everybody
great.
supporting everyone else, talking about, well, my company, we do it this way. At my company, it was a
Really?
wonderful situation. And these were
Mm,
these big companies that are in the, it was mainly attended by Midwest people located in the Midwest. But I have to say, Nick Nanninga is the
mm-hmm.
director of
Right.
CCAT. And SE means Southeast,
Mm-hmm.
but CAT, Center for
Mm-hmm.
Aluminum Technology. This was supported by um, Rio Tinto and
Mm-hmm.
the different primary aluminum suppliers from the UK. And a lot of the faculty was from there, but Nick has assembled a core group of instructors that are also from the US.
Mm-hmm.
And he teaches the lion's share of the class. Nick is a Ph.D. metallurgical engineer from Michigan Tech up
Okay.
in Houghton, Michigan. Um,
Right.
we Rudy Buchheit is the dean of engineering at UK right now, and he is a metallurgist and a corrosion specialist. So to
Right.
get
Mm.
Rudy sharing the podium with him was a very big honor.
A lot
And
of brain power there
yes, yeah.
with that. But
So
you're,
so
yeah, I was gonna say, yeah, I was gonna say, and you're like I said, your company that you still run as a consultant, and what type of projects are you looking to work on, or
well, what I what I have done and what I hope to continue to do is when an end user or a supplier of a product is not performing as expected, to support those clients either through
mm-hmm.
characterization or review of the process or the the um, the performing environment, looking at how this is being implemented,
Mm-hmm.
um, how what went wrong, um, if things are going according to plan, what went right,
Mm-hmm.
comparing the good to the bad, what has changed.
Mm.
So bringing that type of understanding through characterization and sometimes failure analysis, um,
Right.
doing that. Um, the other thing is, if you have a workforce
Mm-hmm.
that needs education and you want a captive type of education experience,
Right.
I'm happy to come in and teach.
Right.
Um, I would be happy to work with a company where they want to develop a new process. Um,
Right.
we want to increase, for example, increase our use of recycled aluminum in our product. How do we go about
Right.
getting
I
a
do.
beautiful finish on that more complex alloy?
Right.
Things
Just
like
being a part of it being just another set of eyes from the outside, and that often helps an organization, I think, sometimes because to ask that question, why are you doing it this way? And like you mentioned before, not just fixing a problem, but really figuring out what went wrong. Like you said, what went wrong so it's not repeated, and
right.
how to get into that. Because again, as OEMs and manufacturers are demanding a higher quality product. Uh, that's who's going to survive is the end users that can really meet that expectation,
Yeah.
really meet all that. And if they, like I said, if they're not operating at that level, they need to because it does make a difference. I feel I hear it from a lot of. I do talk to a lot of OEMs who hire finishers, and they'll say, if we can find somebody that really takes it to the next level and even educates us as the manufacturer on how we can make this better. That is a gold relationship they want to have, and they'll
Mm-hmm.
give them a lot more work with that. So, but that's great. Like I said, and not you're still going to be like I said involved with it, and not to be say a pun, but you're not finished, right? You're not. Don't let people assume that you're
Yeah,
not finished with that, but you're teaching and, like I said, consulting, and I'll put your company's website there. People can reach out to you and
please.
engage you on that.
Thank
But
you.
really, when you look back on this, like I said, someone, the first in your family to go to college, and then you didn't become a doctor, but we'll let that slide. But mathematics and really back, I've even when you were talking that story in the '70s, and I just have read so much about women in engineering and it not being a real friendly environment for them. It sounded like you truly lucked out with some people that really not only wanted to give you the opportunity, but really saw in you some
Yeah.
skills and benefits they're going to get out of it, right? I mean,
Yeah, it's funny, and I see the benefit of having the Society of Women Engineers and different societies that support women in the field. I, with all due respect to that,
and I'll say the exact same thing you're going to say.
with
No
all due
segregation,
respect, I never joined those societies.
right?
And that's because when I would walk into a room and be the only woman at the table, I didn't want to be looked at like the only woman at the table.
Right,
I viewed myself and continue to do so as another professional. I
right,
am that professional. And you brought me into this meeting because you need somebody who knows more than you. So don't let anything confuse you here. You own this company and you've hired me. And so obviously you see something beyond the my gender. And so I really think that I have been successful because I feel that way. I am your engineer. I am your scientist. I am your problem solver.
right. Yep,
And
definitely.
if that makes me arrogant or conceited,
No, it worked, right?
yeah.
It worked, and that's what people needed to take a. Well, I appreciate you taking time out with this, and like I said, and I presenting it, letting our readers and the viewers will kind of watch this, and like I said, it was would be a smart move to give you a call to maybe if they need some help with that. But I do appreciate you taking time out and joining us.
Oh, you're so welcome, Tim. Thank you very much. I appreciate it.